Hello, how have you been? I hope you had a good rest and you're back again with rate of change. Remember the last lesson we had a screeching sound and we're talking about speed, and we try when you want to stop and apply your brakes, then we are moving too fast and you want to make an immediate halt. It's not possible really, so it takes that time and you hear that screeching sound, oh my God, oops. Right? So when you cross the road, cross carefully. No matter when the car is coming so fast, it just can't come to a stop. Safety, my dear, your life is precious. You're young, you're precious, you got a long journey in life. Alright? So let's get back to rate of change. Maths with Kuba will be relaxing, fun, easygoing, and yet effective learning. I'll share with you a little story later on. But let's get back to distance time graph and speed time graph. Now when we talk about, let's get to look at this graph. This is distance, it's measured in meters, and that's time in seconds. And the graph is telling you, hey, right up here at the 10th second, the distance traveled is 50 meters. And then there is a break. We call that rest. Yep. You like to rest, do you? Yep, no movement at all, stationary. So that's an 8-minute rest. And then you continue to move up till 90 meters, and that's 30 seconds. Now we want to find out from this, I want you to change this into a speed time graph. How do we go about that? Now, if you look at the first 10 seconds, the speed, what is the speed in the first 10 seconds? All right, in the first 10 seconds. Now, you'll notice that the speed is the same, it's a constant speed. If I asked you 8 seconds, yes, it's still the same. Now, speed is equal to distance over the time. What's the distance traveled? 50 meters in 10 seconds. And that's about, you cancel, it's 5 meters per second. I hope you got that. 5 meters per second. And, well, that's for every 10 seconds, you're traveling at 5 meters per second. If I ask you for the 8th second, what's the distance traveled? Simple logic. 1 second, you travel 5 meters. 8 seconds, you travel 8 times 5, 40 meters. Excellent. So if they were to ask you, what's the speed at the 5th second, at the 4th second, at the 8th second, at the 10th second, the speed is 5 meters per second. It's a constant speed. So we look at it, maybe this is 5, so up to 10, the speed is 5 meters per second. This is speed. Now for the next 8 seconds, there's no distance moved. Stop still. All right, resting. So 8 seconds of rest. So here, the speed is 0. When you don't move, there is no speed. When you move, the faster you move, the bigger the speed. The slower you move, the slower your speed. Right? Okay. Now, so you look at that. There's no speed. Now here you look at it from 18 to 30 seconds. The speed changes again. All right, here was 5 meters per second. Here is 0 meters per second. Here, there is about 12 seconds. And what's the distance traveled? All right, 90, take away 50, is 40 meters. So the speed in the next, from the speed from, I shall put it as from the 18th to 30th second. They are the same from the 18th to the 30th second. All right? They are the same speed. And what is the speed? The distance traveled from 50 to 90, that's a 40-meter distance, right? And the time is from 18 to 30, that's a 12 seconds. Yep. So if you look at it, divide it by 4, you get 10. Divide it by 4, you get a 3. It's 3 and 1/3 meters per second. It's slower, the next part of the journey. So if you look at it, the next part is 3 and 1/3. Maybe it's here. I shall put it as 3 and 1/3. So this is 0, and this goes up to 3 and 1/3 drop. That's what you get. Have you got it? Alright, I hope you understand, my dear student. Alright? I hope you get a passion for telling me that you get to understand distance, time, speed, time. You're not intimidated. You get to see and read the graph properly. Well, is there any acceleration? No. Why you say there's no acceleration, my dear? Because there's no change in speed here. The speed is constant. So when the speed is constant, the acceleration is a 0. And here, sleeping time, resting time, no speed. And here again, it's just a change of speed. Now you are a bit faster, now a bit slower, but the speed is still constant. As far as acceleration is concerned, all the way 0, no acceleration. Alright, now, and if I ask you what is the average speed, can you be able to tell me? Some people say initial speed plus final speed divided by 2 give you average speed. What? Initial speed plus final speed divided by 2 give you average speed. What talk you? What are you saying? It's not. That's not, my dear. The average speed will be, take note, total distance traveled by total time. Resting is also included. That's called waste of time if you're looking at speed. Alright? So average speed will be the total distance divided by total time. And the total distance here is 90 meters over 30 seconds. So it's 90 meters over 30 seconds, and you will get 3 meters per second. That's the average speed. Okay? What I said earlier on was there's this misconception. You take the initial speed, find the final speed, add them up, divide by 2. That is wrong, alright? So take note of it. So total distance. And another thing, total distance divided by total time. Some people, you know what they do? They said, oh, here we have 50 plus 40 meters, 90 meters. Time taken, 10 plus 12, 22 seconds. So they divide 90 by 22 seconds. Right or wrong? Wrong. Because you're resting. Remember the tortoise and the hare, the story. The tortoise was moving constantly. Alright, they started the race. The tortoise was moving constantly but very slow. The hare moved very fast and took a rest and slept off. And then after that woke up and said, alright, run again. Alright, and it ran to finish line. When it went there, it saw the tortoise already had reached there. Because although you move fast, rest, run fast, now the average speed is during that period of time. What is the total distance traveled? What's the total time? So that will give you average speed. So like that, your speed of learning, please take note, okay? You rest a lot and then after you say, Mommy, I studied so many, my average speed for learning, So no cheating game, alright? Remember the tortoise and the hare. Now let's get back from here. The next graph. That earlier on, what we did was speed time, changing from distance time to speed time. Now, let's look at this graph, my dear. This is speed against time, not distance. Alright? And if you look at here, the speed is changing. Speed here was 0, now went up to 20 meters per second. In how many seconds? 10 seconds. So there's a change in speed. The speed from 0 went to 20. From stationary went up to 20 in 10 seconds. So there is an acceleration pushing the speed up. Otherwise the speed will not move. Alright? When something is moving, alright? When something is moving, it's moving. And then when this is moving, there's something pushing it, so making it faster. And that push force is called acceleration. Alright? Acceleration. And the faster the acceleration, the speed increases faster. If there's no acceleration, the speed is constant. Alright? It just remains the same speed. So if you look at it here, the acceleration, there is an acceleration. And what will the acceleration be here? I'm not looking at the question here. I call this A1. The acceleration will be the speed. You reach 20 meters per second in 10 seconds. So 20 upon 10 will be 2 meters per second squared. Please take note, because it's meters per second. Here is meters per second divided by second. So it is 2 meters per second squared. In this case here, in A2, can you say, teacher, resting? Resting? No. Why not? Because it's a constant speed. It's not distance. So please read your axis. The speed here is 20. 20 from 10 to 20 seconds. There's no acceleration. Constant speed. Very steady. Alright? So in A2, the acceleration is 0. 0 meters per second squared. Now in A3, let's look at it again. A3. What happened? The speed from 20 became 32. I draw a dotted line and say Here, the speed changed from 20 to 32. That's about 12 over a period of 10 seconds. Alright? Over a period of 10 seconds from 20 to 30, the speed from 20 meters per second became 32 meters per second. Something pushing it. Speed up. Alright. So what is A3? The jump is in about 12 meters per second over 10 seconds. That would give us an acceleration of 1.2 meters per second squared. Haha. So you can see, you look at A1, you look at A3. Where's the push bigger? In A1, push, faster, moving, alright? Accelerating. Here is a bit slower, the push. But still, the speed changed from 20 to 32. Now in this case, in A4, what can you say? Constant speed. The acceleration is still 0 meters per second squared. This is called cruising. We have reached a nice good speed. We are cruising. No need any push because it's comfortable enough. 32 meters per second. That's the speed. But the acceleration is 0. When you reach your maximum velocity or your maximum speed, you don't need to accelerate all the time, you know. Maximum speed means no more acceleration. You're constant, you're up there, and that's your maximum. Alright? Okay, take note of that. My dear young boy, young man, young girls, when you drive your Porsche, I know you love to drive Ferrari, Porsche, whatever. When you grow up, be careful. Don't keep increasing and accelerating and revving up your machine. Go on and you go really fast, and then what happened? Pung! Don't regret, alright? So remember, there is a certain amount of acceleration to be done. And once you reach the speed that you like, in Singapore context, it's about how many kilometers per hour, can you tell me? 100 kilometers per hour. Alright? So that's about it. And some places you only drive at 50 kilometers per hour. Tortoises are very slow. Right? In Singapore, but in some countries can go even faster. I remembered when I was in Germany and I had missed the train and I was trying to get to another train, and now I had to really go very fast, and I hopped into a car. Would you believe the driver of the car, it's a taxi that drove at 250 kilometers per hour in that highway. Oh my God, I thought I was flying. I felt good. Woo! But it was dangerously driving. 250 kilometers per hour. Alright? Don't try that here. But because they have that driveway, they have the space, they have the whole length, and it is kind of, that highway is meant that way, you can just go up. Okay? But that's dangerously high here. Now let's get back to this sum, my dear. Speed time. Speed is very interesting. I'd like you to make it in real terms. Understand the concept so that you can apply it in your daily life. This graph shows the speed of a van during a period of 40 seconds. Alright? And the total distance traveled in the 40 seconds. What is total distance? The distance is the area under the graph of a speed time graph will give you the total distance. Unlike, can I bring you over to this first sum? Here, what's the total distance in this first graph? It is 90 meters. Don't go and find area, auntie, uncle, please. This is distance time graph, my dear sweetie. It is a distance time graph. So at the 30th second, you've traveled 90 meters. Okay, this is distance. Look at that. Okay, so now let me shift you back to that sum here. Well, in this graph, what is that, my dear? Speed. Speed time graph. And the speed is meters per second, and the time here must be in seconds, all right? So it clearly spells it easily. So now, if you look at it, they said, okay, find the total distance traveled. So this is not 32, my dear. It is the area under the graph. Now, we look at this graph, and I can see how many trapeziums? Do you see a trapezium? All right, you want to call this as A1, A2, A3, A4 also can. Or you want to call this as one trapezium, two trapezium, and one rectangle also can. So let's look at this trapezium, or maybe I want to look at this, maybe I look at this as A1, make it better and clearer, A2, A3, A4. All right, what is the area total distance traveled? What is A1 equal to? The distance under the graph. Alright, A1, please help me, my dear. 10 times 20 divided by 2. Because it is distance, is a triangle. Base times height divided by 2. So you got 10 times 10, 100 meters traveled there. Alright, it's meters, it's not meters squared, it's distance. Okay, 10 times 20 divided by 2. How about A2? A2 again is a distance. It's a rectangle. Here is 10 times 20. So 10 times 20 will give us a 200 meters. Alright? How about A3? A3 will be, it's a trapezium. A trapezium, you look at the parallel sides, you add up the parallel sides, divide it by 2, multiply by the height. Parallel sides, B1 plus B2 divided by 2 times H. That's the area of this trapezium. What is this length, my dear? 20 plus 32 divided by 2 times the height. This is the height. The height must be 90 degrees to the parallel sides. 90 degrees here, you can see it, this. So that's times 10. So when you add this up, you get a 52. 32 plus 20, 52. Divided by 2, you get 26. 26 times 10, 260 meters. So I said, oh, yeah, 260 meters traveled here. Here, 200 meters traveled. And here is 100 meters traveled. How about the last segment? A4. 10 here times the height here. So A4 will be equal to 10 times 32. You get 320 meters traveled. So hey, 320 meters traveled. Pardon me for this coming in, all right? It's not to be written into the graph, all right? Because I'm teaching you so you would get to see it better. I wanted to write it clearly. So this is the distance traveled at different segments of my journey or the van's journey. So the total distance traveled will be 100 plus 200 plus 260 plus 320. What will that be? All right, in A, section A, total distance, TD, please write it in full, 300, 560, 580, 880 meters traveled. That's the part A. And what is the average speed in B? What is the average speed? All right, average speed is made up of what? Average speed is the total distance divided by total time. Okay, the total distance is 880 meters over 40 seconds. Cancel, ding ding. Divide by 4. You get 22 meters per second. That's the average speed. 22 meters per second. Alright, traveled in the 40 seconds. Alright, you travel 880 meters. Next, what is the rate of change in the speed in the first 10 seconds and the last 10 seconds? I've already done it for you. What is that rate of change? The rate of change of speed is acceleration. How fast is the speed changing? Now, in the first 10 seconds, the rate of change of speed is 2 meters per second squared. In the last 10 seconds, it is 0. It's constant speed. Are y'all clear? So, what you write here, first 10 seconds. First 10 seconds, alright, the acceleration is equals to 2 meters per second squared. Last 10 seconds, alright, the acceleration is equal to 0 meters per second squared. Please put properly, take note. Alright, have you got that, my dear? Alright, we'll go to a little 3 more sums, and then you get a better understanding of speed time before we get to practice sums. And with these techniques, you'll get to see it. The techniques really help you to understand the rate of change. Alright? Okay, foot loose. Loosen up your feet. Get to the toilet, loo, whatever. Get yourself a drink and come back to me. Foot loose. I love that. I'll come back to you shortly on that. Alright? See you.